Okay, this is section 7.2. We're going to be solving linear systems with substitution. So when we finish, I expect you to be able to solve a linear system using the substitution method. So first, I just want to make sure we all know what a system is. Whenever we're talking about a linear system, that means we have two equations instead of one. And because we're talking about linear systems, they must be linear. That means none of our variables have a power higher than 1. Now, we've already used substitution before, but the method we used was really simple. We said we have the equation 4x plus y is equal to 8, and let's let x equal 1. So everywhere we had x, we substituted 1. So we said, okay, I've got 4, plug in 1 for x, plus y is equal to 8. Okay, so 4 plus y is equal to 8. Okay, let's subtract 4 from both sides. So we had y is equal to 4. And that's using substitution. If we were to write this as an ordered pair, our solution would be the point 1, 4. Well, what's different about what we're doing today? Instead of substituting a single number, we're going to substitute an expression. So if I have x plus y is equal to 2, now I say let y equal x plus 1. So everywhere I have y, I'm going to plug in x plus 1. So now I have x plus, and I'm going to insert it in parentheses. That's just a good habit to get into. X plus 1, close parentheses, is equal to 2. Now, I don't have anything outside to distribute. I have a positive sign, so I don't have to distribute a negative or anything like that. So I have x plus 1 is equal to 2. I'm going to combine my like terms. X plus x is going to give me 2x. So 2x plus 1 is equal to 2. Subtract 1 from both sides. So now I have 2x is equal to 1. I'm going to get x by itself, divide by 2. So I have x is equal to 1/2. Now if x is 1/2, what's y? Oh, well, y is x plus 1. What am I going to plug in for x? Oh, I just found it. I'm going to plug in 1/2. So when I want to find y, I'm going to say, okay, well, y is equal to x plus 1. X is equal to 1/2, so y is equal to 1/2 plus 1. So y is equal to 1.5, or you could say 1.5, or you could say 3/2. And if I wanted to write that as an ordered pair, because I'm talking about an x value and a y value, so the ordered pair just kind of makes sense. My solution would be 1/2. Since this isn't a fraction, I'm just going to go ahead and write this as 3/2. And that would be my solution. Now let's take a look at the steps to solve a linear system using substitution. Well, the first thing you have to do is you have to make sure that one equation is solved for one of the variables. And it doesn't matter which variable. You can solve it for x or y, and we're going to show how to decide which one's best. Then you're going to substitute that expression into the other equation. You're going to solve for the variable. Then you're going to plug the solution in to find the other variable. And then we always check our solutions. We're always going to have two solutions because what we're finding is an ordered pair. We're going to have an x value, a y value, or if our variables are different, maybe an a value and a b value. So let's take a look at this one. I have x plus 2y is equal to 1, and I have 2x plus y is equal to 5. Well, I have to figure out which one I want to solve for. And it doesn't matter. It's all personal choice. So if I look at the first equation, I would choose to solve for x because x doesn't have a coefficient. That's always going to be my first choice, is to solve for a variable that does not have a coefficient. Now if I'm looking at the second equation, I'm going to choose y to solve for because y doesn't have a coefficient. So in this case, I'm just going to solve for x. I'm going to use my first equation. And I like to write little notes. So for this one, I'm just writing that I'm solving for x. So if I have x plus 2y is equal to 1, I solve for x, subtract 2y from both sides, subtract 2y. So I have x is equal to negative 2y plus 1. Now I need to substitute. Everywhere I have x, I'm going to plug in negative 2y plus 1. So now I have 2. There's my x. So I'm putting in negative 2y plus 1 plus y is equal to 5 because I have to put in the rest of my equation. So now I'm just going to distribute and go through like I would solve any other equation. So 2 times negative 2y, it's going to give me negative 4y plus 2 plus y is equal to 5. I'm going to combine my like terms. Negative 4y plus y is going to give me negative 3y plus 2 is equal to 5. I'm going to subtract 2 from both sides. So now we have negative 3y is equal to 3. Divide both sides by negative 3. So now I have positive y is equal to negative 1. Now that I've found y, I need to go and find x. Now, I could use either one of these equations if I wanted to, but I want to use this one because the variable x is already isolated for me. So I'm going to say, okay, I've got x is equal to negative 2 times y plus 1. Well, what's y? Oh, y is negative 1. I'm going to substitute that in for this y. So I have x is equal to negative 2 times negative 1 plus 1. X is equal to positive 2 plus 1. So that means x is equal to 3. So my solution for this equation looks like it's going to be the point 3, negative 1. But one thing that I always want to do is I want to check my solution. Make a little box down here to check my work. So for the first one, see I have x plus 2y is equal to 1. My x value is 3. Plug in negative 1 for y. I'm going to see if that's equal to 1. 3 plus a negative 2, same as 3 minus 2. Okay, well that gives me 1, so it checks out for my first equation. Let's try the second equation. So for this one I have 2x plus y is equal to 5. So I have 2 times 3 minus 1. Okay, that gives me 6 minus 1. 6 minus 1 is 5. So the solution 3, negative 1 is correct. So what I've just found is the point that if I were to graph those two lines, where they intersect. Now let's look at a different one. I have x plus 5y is equal to 2, and I have 2x plus y is equal to 4. Okay, now it doesn't matter which one you choose to solve for. I'm going to solve the second one. Do you know which variable? Y. And I'm choosing y because y does not have a coefficient. So I'm going to solve this one for, I'm going to subtract 2x from both sides. So now I have y is equal to negative 2x plus 4. Now every place in this first equation, this top equation, there's a y. I am plugging in negative 2x plus 4. So I have x plus 5 times, I'm going to plug in negative 2x plus 4 is equal to 2. Notice the only variable that I'm working with right now is x. So I have x plus, oops, let me distribute. Positive 5 times negative 2x, that's minus 10x. 5 times 4, that's going to give me a plus 20. Is equal to 2. Combine my like terms. I have negative 9x plus 20 is equal to 2. Subtract 20 from both sides. So now I have negative 9x is equal to negative 18. Divide both sides by negative 9. So x is equal to negative divided by a negative is going to give me a positive, is equal to 2. Now I need to find out what y is. I can use either of these, but I want to save time, so I'm using y is equal to negative 2x plus 4. Plug in 2 for x, so y is equal to negative 2 times 2 plus 4. Y is equal to negative 4 plus 4. So y is equal to 0. Is it okay to have 0 for an answer? Absolutely. So my solution appears to be the point 2, 0. Remember, your x value always goes first, your y value goes second. So when x is 2, y is 0 when you're talking about this system. Okay, now let's go through and let's check our work. So for the first one, we've got x is 2 plus 5 times 0. We're hoping that's equal to 2. So 2 plus 0 is equal to 2. This one works. Let's check the next one. I have 2 times an x value of 2 plus 0, and I want that to be 4. Well, 4 plus 0 does give me 4. This one checks out. So that's all there is to it. So I have one more on here, and I want you to work on this one yourself. Go ahead and hit the pause button, and then I want you to come back, and I'm just going to have the worked out answer for you. So hit pause. Okay, so I want you to check your last answer. So the solution for the last one is the point 1 for your x value, 1/2 for your y value. If you had trouble with this one or you didn't get the answer, I want you to go back and I want you to rework some of the problems that we did earlier and maybe even review it again. Thanks. Have a good night.